cover a lot of things of interest. So I'm going to talk about woodlands and forests, and I'm also going to talk about wildfire preparedness after this one. So let's go ahead and get started with that. So my basic goal here is really to make sure we stir you up and get some questions and answers going. A whole lot really depends on where you're coming from in terms of your goals and objectives, what you're managing your land for and what you think you can do and what you'd like to do with it. So my job as an extension forester and educator is to help people learn about successful practices and also kind of some of the challenges to watch out for, the general important things to know about woodland management in your situation, which is a very broad topic. So I'm going to cover some things that I think are important that often come up when I work with woodland owners and rural landowners. And then the goal is to give you some ideas and give you a stepping stone to the next conversation or connecting with other resources, whether that's me or somebody else. So let's get going. So one of the things I like to kind of show folks this map of forest ownership. So any trees and woodlands that you have, if you're not industrial owners and you're not a public entity, then you're a private family forest owner is one of the ways we look at people with trees and woodlands. And if you look at this map, you see that kind of a pink color is what it looks like to me, or purple. And around the Willamette Valley and here in Marion County, you see that most of the private small woodlands family forest owners are kind of in the lower elevation, the valley fringe, very concentrated. And as you go up into the mountains, you get into the deeper in the woods with the larger owners, either public or private. So our forests, I am a woodland owner, I have 15 acres as well. They're really an important component of our kind of closer to where people live and more of the developed landscape. And the forests and habitats that we own and manage are really important for people and close to people, as well as the unique types that are in the lower elevations of the valley and the valley margin, as opposed to up into the mountains. So we have some special habitats that we're all trying to manage, and also for our own other goals besides habitat, of course. So of course, one of the most important things to know is the trees. And wherever you are in your knowledge and learning, we want to be able to help you get to know your trees. So here's an example of two sources of good information about it. I'm not going to try to explore all the details about our main tree species right now. We'll touch on a lot of them, but good references here. The Trees to Know in Oregon, nice illustrated book, as well as the online kind of version of that same thing, Common Trees of the Pacific Northwest. And there's a website there. Yes?
I just want to let folks know that this presentation is in the presentation folder on the shared folder online. So you'll be able to you don't need to try and scratch this down right now. You'll be able to find it online.
Yeah, thank you for reminding us of that, because you will have this to refer back to. So that, and also I loaded up some more documents with links to all kinds of websites and things that I'm going to talk about in the resource files, as well as the presentation itself. So, and actually another really good resource, especially when you're thinking about planting trees or establishing new trees, is this publication, which was just updated this year, Establishing and Managing Forest Trees in Western Oregon. That's also an online resource, and you can download it for free. You can also get color hard copies if you order it from the Oregon Forest Resource Institute. So this one is a great one. And as an example, we'll kind of get right down to some of the important information here. If you look at a list of the major tree species that you find in Western Oregon, particularly around the Willamette Valley, and you start to think about where on my land should they thrive and where might they be challenged, and what are the challenges out there? What makes a good place for a Douglas fir versus a ponderosa pine or a grand fir or a cedar or a hemlock? And so this shows, a rating of how do they tolerate, shade, low light levels? How do they tolerate animal damage or browsing? What about wet soil, which is a common issue? It's either too wet or too dry, it seems like, in a lot of our areas around the Willamette Valley. How about drought, the other end of the spectrum? How about frost? Do they tolerate that? And if you look at Douglas fir, for example, so the lower the number the lower its tolerance, the less it'll tolerate it. So ponderosa pine is the least tolerant of shade. It needs the most sunshine. It's pretty tough when it comes to animal damage. It can also tolerate wet soil, which is a miracle for the Willamette Valley. If you can't grow anything else, you might be able to grow up a Willamette Valley ponderosa pine on low sites in the valley that are wet in the winter and dry in the summer. Also very drought hardy. And then, other end of the spectrum, our western hemlock, very tolerant of shade, not tolerant at all of drought. So you can see, you can use this kind of guide to sort of match the species to the site conditions that you're getting to know on your land. Then, of course, there's a long list of hardwoods like our Oregon white oak and the maple and alder. There's a lot of important information here, and also knowledge that I have and others that can share with you about trying to understand where the species will do well, where you have to watch out that they might not tolerate the site conditions. So this is in this version of this is in that publication there. We have a number of different versions of these out there. So it kind of comes down to the next thing after you get to know your trees and where they might do well and where not. Then how well do you know your land and the climate and the environment? And that is the challenge, and also the important step that you need to take is to get to know that, especially in terms of the climate variability and extremes. And I'll talk about that some more. How bad is the worst drought they're going to see, and what's kind of the usual condition as well as the extremes. And then this varies, of course, what side of the mountain you're on, if you have a steep slope, if you're facing south or north, or if you're in a low area that floods, getting to know all those aspects of your site and the environment. And of course, then your elevation. I'd be kind of curious to know, one of the things I miss is I usually start out by looking at where everyone's from and asking a lot of questions at the beginning, and getting to know you and where you are. I don't have time really to do that in this venue, but and then of course you had a session on soils. Did they have that session already? We'll be
The
talking
first
about,
day.
yeah. So, and this is an example in terms of you know, the drought or the extremes. Here's an example from weather stations over the last 20 years, looking across some of my territory, Salem or Estacada or Hood River. You can see that, sometime in the last 20 years, there's been a year where, Hood River got less than a half inch of rain all summer long. And so, knowing what this is like in your area, in your particular site, what's the worst year they're going to see in 10 or 20 years? And of course, trees live a long time. So you might be thinking more like 50 years, and you wouldn't want to plant something that's going to end up dying when it's only 30 years old, such as some of the Douglas fir we've planted in the wrong places out in the valley, that kind of thing. So knowing kind of what the extremes are, and again, moisture is a key, summer moisture and drought, and the ability of the soil to hold that moisture is kind of the next thing. So if you match up what's the worst drought that you might see, and then what kind of moisture supply does your soil have to get trees through that drought? And so if you have one of the more common forest soils, the Jory silty clay loam, for example, that's the state soil of Oregon. It's one of the more common forest soils around the valley margin. And that soil is fairly deep, it's well drained, it's great tree growing soil, and it holds often 10 inches to a foot of available water for plants. So after it stops raining, that Jory soil can supply 10 to 12 inches of water. And that really helps trees get through a drought. Whereas you get down the list, I chose another soil that I ran into, called a Rittner silty clay loam. And, it's a shallower soil, and it only holds about 4 inches of available water. And so how long does that last during a drought? And then you get to some of the really challenging soils, like a hardscrabble soil is actually the name of the soil. It tells you a bit what it's like to grow there. And that is poorly drained. It's shallow. The water actually drowns the tree roots in the winter and spring. And then when it dries out in summer, it can only hold about 3 inches of water. So if you have that soil, which might be analogous to some of those sandy, cobbly river wash soils that you have, say, in the San Am Canyon, it doesn't hold much water. And that's why trees are often dying after severe droughts. And it might be a 10-year or 20-year or 50-year drought that makes the difference. Another good way to get to know your site conditions is just looking at what's growing there. So if you have native forest vegetation, the vegetation type, the combination of species, it really tells you a lot. So I'm just using an example from a forest that I work with near me, the Hopkins Demonstration Forest. It's about ranges from 400 to 700 feet elevation south of Oregon City. And on our driest rocky site, we have madrone, poison oak, and Douglas fir on a rocky site. It's pretty dry, kind of southwest facing slope. That tells me it's kind of a dry site. Down the hill a little bit, I have a forest with salal as a common understory plant, and maybe some Oregon grape. And that's a moderately drier site, better than the poison oak and madrone. And then just down the hill a little bit across the way, there's more of a sword fern understory with Douglas fir that's much more productive than this Douglas fir with salal understory. So the vegetation indicates a lot about the conditions if you have native vegetation to look at. You go to the very wettest site when you have lady fern and devil's club that really indicate a very wet site, for example. And these things, we have good guidebooks and things like that. Another aspect of your forest, of course, is what is the natural fire return, or the fire regime is a term that we use. And our Douglas fir in the valley foothills and the Oregon oak woodlands are in an environment that typically had burned fairly often compared to the denser, moister forests up in the mountains. So, in the last 50 to 150 years, fire is to be expected in our valley margin Douglas fir forests. Of course, a lot of that was driven by historic conditions like Native Americans being the source of ignition and lighting fires to manage the valley. Further up in the mountains, the more moist forest conditions, fire doesn't happen nearly as often. It's not dry enough, and you don't have the probability of a spark very often, et cetera, if there's not a lot of lightning, which there isn't in Western Oregon. Of course, humans are out lighting fires, and we'll talk about that later. So that's another aspect of the forest, that are all the forests in Western Oregon are driven by fire at some interval. Another thing you want to get to know are kind of what some of the threats are. And my job, I get an awful lot of questions about what's killing my trees, or what might kill my trees, or is my forest healthy? And what should I be worried about if something's waiting to get me? So that's a common situation. And you can always contact me with those questions, because I become very familiar with a lot of the threats and the situations there in our forests over my career. But we kind of look at what we call biotic agents, which are diseases or insects, and there are some virulent diseases or dangerous insects that can just outright uh, wreak havoc and kill trees. Um, More often than not, though, the thing that's killing our tree is more of uh, abiotic agent, such as a drought stress or a cold snap or a flood or a windstorm, and then it sets the tree up and makes it vulnerable to some of these biotic agents like diseases or insects. So we can identify what those threats are and kind of look at what we might be concerned about, and that might influence how we manage and what we grow and that kind of thing. I'm going to touch on a few really common ones here, because the drought in particular, interacting with diseases and insects, has been one of the major issues of late, and actually always has been, but we've had a pretty severe drought cycle over the last 5 years. So in this case, we talk about what is killing the trees, as in this usually is an interaction of both the biotic and the abiotic or weather type factors. So for example, this tree right here, dying Douglas fir out on a grassy site in the Willamette Valley. The culprit is a drought stress and a stem canker fungus, which is very common on drought stress Douglas fir on what we call kind of a marginal site condition, where it's a little dry for Doug fir. And the fungus takes advantage of a weakened tree and advances. It's somewhat counterintuitive. We think of a fungus being something that likes moisture, but this fungus is actually out there in most Douglas fir, and it only really becomes a problem when trees are really stressed. Red alder is a common victim of a similar kind of thing. Red alder in the Willamette Valley margin is pretty sensitive to the hot, dry summers, And even when it's well watered, it'll get a drought and stem canker interaction, kind of like the Douglas fir, which is what I'm showing here. Uh, White alder actually is a more well adapted to the drier, hotter summers in the valley along riparian, stream sides, for example. Douglas fir, in this case, just a 30-year-old Douglas fir competing with itself, with each other, is one of the more stressful forest stand conditions. And then with drought cycles, you often see some patchy mortality where the competition stress and the drought makes trees vulnerable, and then the insects move in this case, a flathead fir borer that attacks drought-stressed Douglas fir. And so we can identify these different kinds of interactions and kind of help you, predict where it might happen and where it won't. Now, one of the most common disease threats to our forests in this area are root diseases. There's estimates that as much as maybe 10% of the ground in Northwest Oregon has a root disease, which in this case, Douglas fir in this patch were killed by root disease, and then drought and bark beetles sort of ganged up on them. But they had the root disease to begin with, which was the primary factor that disposed them to this Douglas fir beetle that came next. And these I know well, and we can look at trees and see if this is happening. Bark beetles leave a very distinctive pattern under the bark. And the Douglas fir beetle, you can identify just from this pattern of the beetle galleries underneath the bark. And these little bark beetles are only about an eighth to a quarter inch in size, and they kill the tree by attacking in the thousands. Back to the root rot, the most common and deadly one around here is laminated root disease, and it's very distinctive and identifiable. And if you have an area with it, then you want to map where you have it, and don't plant Douglas fir in that area. Again, plant something else or encourage something else coming up that's more resistant to the disease, such as a cedar, a maple, or a pine in this case. And again, these are things you can learn more in sort of the advanced class. Something happening recently is our western red cedars in kind of low elevations, 500 to 1,000 feet. We're seeing a fair amount of cedar dieback, which we are also attributing to drought stress. But it's interesting where it happens and where it doesn't. So we don't have all the answers yet. Does seem to be associated with the wetter sites that have shallow soils due to high water that then dry out in the summer and don't have as much of a rooting depth for the trees when the drought hits in summer. And if you're kind of a climate tracking geek like I am, in part just to understand what's going on with climate and see what our trees are up against, this site here, the PRISM Climate Group, which was originated out of OSU, is a great place to go and look at past data on climate and how it may be changing, or just the cycles of extremes from one year or decade to the next. And you can zero in their data explorer and look at your particular part of the world, and it will interpolate and tell you its best estimate of what the rainfall, temperature, other factors have been, and often over the last 100 years. And I use that in my investigation of, what's killing the cedar, for example. Why are 80-year-old trees that have been really happy all this time, are they dying now with no obvious insect or disease? And I looked at that site, and I looked at a more complex climate variable, which is really just, it's both the heat and the drought, but it's actually the atmospheric drought or low humidity. So when we have less moisture in the air, lower humidity, and we have higher temperatures, that sucks the water out of the leaves more forcefully. So I call that moisture demand. And when I looked at the moisture demand from climate data, the drought in 2015, 2017, and 2018 edged up a notch higher than the trees have seen in 50 years. And that's 3 years in the last 5 at the time I was looking at this. So that alone just explains, well, they're just seeing a little more atmospheric demand for moisture than they've seen before. And so some of the trees that used to be really happy, they crossed the threshold and they couldn't get the water up to the crown. They suffer from actual cavitation, an embolism basically, and they can't get water to the top and the tree dies. So these are things that we can look for and help you interpret. So when you look at, how do you manage trees and keep them healthy, which is a question a lot of people have, there's a kind of a checklist that we go through. And the start is, do no harm. Don't don't change the drainage or pave the rooting zone or bang the trees up with your equipment or compact the soil, etc. But then also the more details about knowing what your soil and site and environment is like and kind of understanding what to expect for these different tree species. And maybe when one tree is in trouble, like the cedar's dying, for example, then you say, maybe I should plant something else here next time. So choosing species that are well adapted and not putting the wrong tree in the wrong place is a key part of really of prevention. And then paying attention, monitoring what's going on, and in some cases then removing unhealthy trees that are infested with insects. Um, if you identifying a root disease when you have it and not planting something back that will get that same disease. So that we call that sanitizing. The disease will die away. Um, avoid attracting or introducing pests, that kind of thing. Another important thing for woodland owners to be thinking about, of course, is planting or reforestation. And kind of talked about that already in terms of matching the species to the site conditions, planting the right thing. But then if you're looking at getting seedlings in forestry, we're used to getting trees by the thousand to plant because on many acres you plant thousands of trees. We usually like to plant a tree that costs about 50 cents and the nurseries are there producing them. But you have to order early. Usually it takes 1 to 2 years to grow a seedling and you generally want to order that far in advance. And especially now, it's difficult enough for woodland owners to get seedlings. We're competing with high volume purchasers out there, and we are generally low volume purchasers. And the nurseries don't like to sell less than 10 or 20,000 at a time for reforestation. And right now, the demand is much higher because of all the fires. So just a warning there, if you're thinking about planting lots of trees, you probably ought to get in touch with me and check the outlook for tree seedlings. But we estimate every year we plant around 40 million trees in Oregon, kind of average. And with the fires that have happened, the demand is more like 100 million trees for Oregon. So that's a bit of a bottleneck right now. But once you've got some seedlings and whether you're buying them or even transplanting them yourself, handling them correctly, giving them a good safe place to grow amidst all the competing vegetation like grass and blackberries and Scotch broom and things like that is really important. Understanding what animal threats, animal damage threats there are. If there's a herd of elk that likes to go through your property or the deer really hang out in a certain place, they will harass your trees quite a bit. And there's things, of course, you can do to protect them, like put little cages around them or invite your relatives to hunt that particularly part of your property, whatever it takes to reduce the pressure for a few years. And when it comes to planting trees, there's a right way and there are many wrong ways. And so I just have this illustration as an example of planting our little forestry seedlings. Um, you can plant them too deep, you can plant them too shallow. The most common is what we call a L root or a J root, where people don't dig a hole deep enough and they stuff the roots in there and they're then bent over in an L or a J shape. And that sets the tree up for a lot of problems. They may die in the first 5 years because the roots just don't form properly and access moisture or nutrients. Or they might not die until they're 30 years and they fall over because of a deformed root system. Deformed root systems are usually persistent. They don't necessarily correct themselves. So if you look at the lower right, the properly planted tree, everything just right. Sometimes planting bare root, these are examples of bare root seedlings, is more challenging than planting a small, containerized potted tree. In our case, we use what we call a plug seedling, which is more of a, just like a plug that's, you know, bigger than your thumb, but more like, the size, about a 2-inch diameter by 8 inches deep root, root plug. Here's an example of a site where a small clearing where we planted trees. These are going into their third year. We did a fair amount of weed control. We planted good quality trees, and they looked like they're getting established pretty well. The Douglas fir amidst the winter dried grasses there. Here's another site where a landowner planted about 3 years before, and you can't find any trees. What happened to the little trees? Well, the difference is that the soil on this site was that nice jory soil that holds a lot of moisture. And even with this amount of competing vegetation, which is still, there's a fair amount of other vegetation here, the trees were able to thrive, and they weren't um, really drought stricken because of competing vegetation getting all the water. Whereas on this site, this is one of those soils that doesn't hold very much water, and they did not do as much to control the competition, and their seedlings didn't survive. So that was something they might have anticipated it, and done a little bit more work on weed control, for example, because that's the main factor that reduces the moisture competition and increases available moisture, is to control the weeds. And once you've succeeded in having established trees, or if you already have a patch of trees, there's of course a lot of different um, options for how we manage the forest, depending on our species and our conditions. And for each of these topics that I'm talking about, we have a series of classes, say in our tree school online, or workshops that we like to do in the field, sessions of all about reforestation, or all about how to manage forests at different ages. So I'm just touching on this example. Um, this is a stand that we work with in our Hopkins demonstration forest. When we established that forest 30 years ago, this stand was about um, 50 to 60 years old. And we decided we wanted to keep thinning it and kind of maintain it as more of a maturing forest. Um, and this is after 30 years of doing that. The question what we do next is going to be important. There's a choice of, do we want to start over again, or do we try to keep thinning it and letting these trees keep getting bigger? Uh, One of the key um, principles of how we manage trees is understanding the space that a tree needs to grow and be healthy. And either competition with weeds, the weeds use up growing space, they compete for moisture, nutrients, or light, or competition with other trees, the spacing of trees and how crowded they are. And also a thing that we often look at doing is pruning for various reasons, which I'll touch on later, either for just being able to see through the woods and access to walk underneath them, as well as separating the fuels from the ground, so that for fire hazard mitigation, as well as improving the quality of the wood. If you're selling the log, having no branches means no knots, which means higher quality wood. But one of the principles here about this growing space is that the amount of sunlight and water and nutrients and actual physical space, is a fixed quantity. And so if a tree is large, of course, it needs a lot more of all those things. And when trees are small, they need less. So at an early stage, we often start with 300 to 400 trees per acre in our planting. That's 10 to 12 feet apart. By the time the tree gets really large, it actually may need more like 20 feet or 30 feet to its nearest neighbor. And understanding kind of how that's going to change and when might be a good time to thin them out is a key aspect of managing forests. Now, keep in mind that in nature, other than accidents of storms or insects or disease or fire, stands often grow for many decades with no thinning, and they self-thin. The trees kind of fight it out, even if they all start at about the same time. You'll have trees that emerge to be dominant, which is indicated by a D, or co-dominant in the canopy. But there are trees that end up falling behind, and they become suppressed, or they die, as in the case of that tree labeled M here is mortality. So natural forests tend to do this, and they compete with each other, and it may take hundreds of years for the forest to look the way you see it today after self-thinning and these things happening. But when we want to manage the forest, we often want to thin it out and give trees more growing space. And so we've learned over the years, well, how much growing space does a Douglas fir need, or an alder or a hemlock. And the different species of trees use different amounts of space. So what's interesting here is the Douglas fir, kind of middle of the road, But we've done a lot of studies and determined that if you have 10-inch trees, a little more than 300 per acre of Douglas fir is about the threshold of where they would start to kill each other through competition. The maximum biological density we've ever seen is closer to 600 10-inch Doug fir trees in a very dense stand, and an acre won't hold any more than that. But if they're hemlocks, you can pack a lot more in. Hemlock is a different species and has different biology, and it can grow a lot denser for the same size. On the other hand, alder or pine, you cannot have nearly as many trees on an acre before they start to kill each other for competition. An extreme example of that is out in Eastern Oregon, a juniper tree, you can have 5 per acre and they're fully occupying that acre. And here's a key concept that we use when we're looking at trees and we're kind of intervening and deciding which trees we want to leave and which ones to take, or what makes a good stable tree. And the crown ratio, or the amount of the tree height that has green branches, is really a good indicator of how stable and vigorous and healthy a tree is. And if you look at these trees here, these would all be the same age in this. Let's assume they're all the same age, which often happens. So they're about the same height. But some trees on the left have been growing in a dense stand and they're very tall and skinny. They're not stable. If you were to remove their neighbor, that tree might fall over in the wind because it's not able to hold itself up. And the trees in the middle, more like a 40% crown ratio, is getting to be a pretty stable tree. It also has a big factory. That green part of the tree, the crown, is the photosynthetic factory. So it's got more leaves to make more food to grow better. And on the far right is the extreme, and you've probably all seen this, a totally open grown tree with branches almost down to the ground, green branches, and it's the biggest factory a tree can have. And I've seen trees like that have 1-inch growth rings, like a big sequoia or Doug fir grown in the open. So we can choose if we want to grow trees that are more like the ones in the middle. It's all a matter of how much crowding we allow to develop, or how far apart the trees are in this simplified case. But it's a good way to look at trees and see how vigorous they are. And in the case of, again, crowding, stands grow and become more crowded over time. And so that this was a stand that was planted at 400 trees per acre, 10 feet apart, in this case, 28 years prior to this picture. And by the time they grow up to this size, they completely dominate the site. There's nothing growing underneath it, and it's lights out with Douglas fir at 10-foot spacing after 28 years. It's not, the trees aren't quite dying yet. They're not at that threshold of killing each other, but they're fully occupying the site. They're fighting it out. Trees are going to start dying pretty soon in here. But that same stand that was planted at 10-foot spacing, if we'd have thinned it at around age 15 in this case, it would be a whole different stand. We would have bigger trees, bigger crowns, stable trees, options that we could keep thinning if we wanted, and the trees wouldn't be so weak that they would fall over. And then we have an understory. We have native vegetation persisting underneath. Whereas in this stand, we've lost whatever understory there is, and there's really nothing here but Douglas fir. And if we wanted something growing underneath it, we'd have to work hard to get it back. In fact, if you thin this now, the things that come back first would be often the weeds, the things that the birds bring in, like blackberries or other things, and also things that blow in on the wind. And the native understory, such as sword fern and vine maple and elderberry in this stand, they're not here, and they might not come back for a while. So that's an important part of how we might manage our stands over time. And bigger picture, the approach that you take to growing trees, whether it's 1 acre or hundreds of acres, we often decide, are we going to clear an area and plant them all at once, which we call even aged management, somewhat analogous to a fire that kills all the trees and then stuff seeds in a fairly short time and they all grow up together again. Or in this case, clear cutting, then all the trees come up at the same time in patches that we call even age management. And that is, as you probably know, looking around Oregon, that's the most common practice on managed forests. It works really well for growing a crop of timber trees. But there are also other approaches, and especially for smaller acres where we don't necessarily want this sort of all or nothing approach with larger clearings, can't we just selectively thin and selectively manage and make a hole in the forest and let new trees grow up in it? Illustrated here, you can see a stump in the foreground, and this is an area where we're trying to manage a mixture of ages and let, um, with selective harvesting and thinning, have a mixture of ages and species growing up, and never have a clear cut in this 10-acre patch, for example. But it's really also very challenging. That's actually not the way Douglas fir and and let's say lodgepole pine or other kind of fire adapted trees tend to grow. They do tend to come back after something comes and kills a bunch of trees. Uh, and in this case, if we're trying to grow trees in a small gap, there's not enough daylight, for example, in a quarter of an acre to grow very vigorous Douglas fir. Although we could grow a shade tolerant tree, such as a western red cedar, a hemlock, or a maple. So it would change what you can grow, and you might need larger openings if you want to grow a pine or a Douglas fir, for example. And another thing we do is we just keep thinning the forest, because Douglas fir can live hundreds of years. And why not just keep thinning it and let it get older and older? And some of us are doing that as well. There comes a time when you wonder, well, once the trees are getting closer to 150 feet tall, it's obviously quite a challenge if you're going to try to thin that or remove any, but you could also just let it go for a long, long time. So then another key aspect of this, the things to know, is if you are going to be intervening or managing your forest and you want to change, the main thing we can change are how many trees are established, and then over time removing trees and changing the spacing and the crowding and the number of trees, which, as I showed earlier, has a big influence on the way the forest looks, whether you have a understory or a dense shaded area in younger forests especially. So how do we remove bigger trees? Well, we need equipment, we need machines, we need to be able to move bigger pieces of wood around, even if it's only just in the name of our management, not necessarily just to make money, but we want to change the forest by thinning trees and we want to let more daylight in. Well, we need to be able to move the trees around, and there's a lot of different approaches to that. In this case, there's a mechanized harvesting machine that makes it pretty easy to work in smaller, younger forests. Um, and then you need the trucks to load and remove the logs. And of course, if you would like to make money and help pay for things, then you sell those, such as this log truck load going to the mill. In younger stands, of course, we might not be having anything big enough to sell, but we would be cutting trees and removing them just to make more growing space. And there's a lot of different ways that we can do this, from the horse logging to the small farm tractor with a winch, to a larger, track skidder or rubber tired skidder, uh, are the common ways that we move pieces of wood around. So I've just really, touched on a lot of the key aspects of things that are important to know if you're trying to establish and grow and manage trees, uh, and make them, the forest, meet some of your goals and objectives, if you're going to lift a finger to manage it. It's also important to understand what might happen if you do nothing, and that's also a management decision. And the nice thing is you can let trees go for many decades, and of course they grew for hundreds of years without a lot of intervention. So that's obviously an option. But understanding what happens if you don't, for instance, if you inherited a patch that started at 400 trees per acre, what if you choose to do nothing? Um, you can see what might happen there. So sources of assistance, starting with me and the OSU Extension Service, of course, as a public um, source, your tax dollars pay for that. But there's also a lot of other sources of public assistance, the Oregon Small Woodlands Association. There's a small fee, dues to join that. The Oregon Forest Resources Institute is also a state agency that does a lot of forestry education and outreach. The Tree Farm Program, your Oregon Department of Forestry, they're really essential people to work with. If you're doing much of anything with trees and woodlands, you should get to know your stewardship forester and consult with them. They provide a lot of assistance. They also enforce the forest protection laws, and so you want to understand those, which I certainly can help you do, but the Department of Forestry is an important part of doing that. And of course, then your Soil and Water Conservation District, who's our organizer here, and the Natural Resource Conservation Service are all good agencies there to help us with managing woodlands and rural lands. Uh, then, of course, there's a lot of private assistance that you may need. If you're doing any kind of larger harvesting or timber sales, oftentimes it really is helpful to hire a consultant to really help manage all of that and make sure that things are done right. And they would manage, the logging contractors, the reforestation contractors, et cetera. But you can also hire those contractors yourself. You can work directly with loggers, hire someone to help you with reforestation, hire somebody or crews of people to help with acres of vegetation management. That would be like, what do you do with blackberries and scotch broom on 20 acres? You can hire wildlife biologists and consultants to really help you enhance wildlife habitat. Same with wetlands and riparian management. Of course, your watershed council and your soil and water conservation district can connect you with a lot of those kinds of resources. And then how do you pay for this? How do you manage some of this if it costs money or more than your time and effort and your own, abilities? Of course, profits for managing if you are able to sell some of the wood. Um, and we have a lot of courses just focused on how do you manage a timber stand and do it efficiently and make financial returns. There's a lot of good grant programs and conservation and restoration oriented programs that I'm sure you'll tap into through this class, this series. They're either direct funding or cost share. You do some and they do some. You can even get loans. You can borrow money on some on timber even. Um, there's and tax credits and other things that can help make it easier to do financially. And then for me as an educator trying to help you, not everyone learns the same or prefers the same way to learn, and so we offer a lot of different ways of learning. A bit limited now with COVID, but workshops of various kinds, which is more hands-on, more how do you do this, let's show you, let's try it together. Classes, of course, in the classroom or by Zoom. Field tours, I really like field tours where we go somewhere to learn about planting trees, protecting trees, weed management, thinning, roads, wildlife habitat enhancement, fish enhancement, all kinds of things that you can look at on field tours and learn from what others are doing and have experts there to kind of share what they know looking at specific situations. Especially now we're really have a lot of reading material, a lot of online material for you, videos, demonstrations, and then articles and things to read. And thing that's still easy enough for me to do is one-on-one visits. Been doing more of those during COVID times on the phone, by email, and even field visits are easier for me, to do because that's a safer thing to do now. But that's something, of course, I always like to do when I can. So I am available if you would contact me and schedule a visit. It might take a while right now for me to get to you because I'm pretty overwhelmed with the fire response that I'm having, but nonetheless, you should call me or email me if you would like a field visit. So, as an example of a field workshop on riparian plantings um, and a one-on-one consultation with the landowner. So another aspect of this is that if you're really interested in learning more and doing more with trees and woodlands, is that there's a woodland owner community, there's a forestry community, and if you're not already kind of tapped into that through extension, through this Oregon Small Woodlands Association and people you meet, even in programs like this, you can really learn a lot and also get help and resources from your neighbors and from others managing woodlands. And of course, we tend to have things in common here, which is most of us have a great appreciation for trees and forests. So there's a starting point of things in common, but there's a lot of experience out there you can learn from others. Well, also we're nearing the end of the woodland session, and I normally have people ask questions all the time as I go. I haven't actually seen the chat. I suppose I see there are some things in there. Okay. Um, that's something that maybe someone should have interrupted me because I didn't see chat things popping up. But I'm ready to start with that. So, just reviewing the things to know, the most important thing to know is kind of where you're coming from and what your objectives and goals and expectations might be. As you learn more, you might adjust all of those. Adjustments for reality is what I call that sometimes. But then again, getting to know your trees, knowing what you have, learning about the actions you might take: reforestation, forest management, forest health, etc. Forest protection is a health, as well as fire protection, which I'm going to talk about in the next session. And of course, a lot to learn about watersheds, which I'm sure you're tapped into. Let's see, oh, there it is. All right, well, let's open it up for questions.
I can start reading. We have quite a few. We actually have a lot of folks that are interested in your fire talks coming up too, because there's a number of people that had their properties burned. So there's a lot of questions on the forestry side of things.
Excellent.
So our first one, where is the best source of info regarding the market price for oak and maple? I have a mixed species stand that I want to try to remove the hardwoods and replant to conifers. Will the hardwoods harvested pay for the logging costs?
Oak and maple don't pay as well as alder, for example, but all it really depends on the quality of the trees and the wood that's there. Particularly the Oregon white oak is more of a specialty product, but there are mills and kind of specialty companies that make flooring and lumber and higher value products out of Oregon oak. Maple as well. They both have a pretty good value. If you have a nice log, if you end up with a nice log, at least usually 10 inches in diameter and 10 or 20 feet long, there are mills that would like to buy those. The question is, how many of those logs can you get from this project? What does it take to cut them and deliver them to that mill? And it's usually, per acre, it doesn't usually add up to a lot, but I can definitely help connect you with those mills. We have a directory of who those buyers are. And the more you want to do your own value added, that somewhat times appeals to people. There are small scale mills that you can work with. They might just actually, go in on it with you to develop the lumber product and then find somebody that buys it. But I wouldn't expect a high rate of return per acre, but they definitely have good value. Is that good enough?
Yeah, yeah.
All right.
Next
Well, and
question.
contact me with those questions, of course, and email these days is the best.
Okay, so what was the laminated root problem on Doug fir? A disease that stays in the soil or a soil problem?
Yeah, I mean, it is a disease of the soil in that it lives on the living tree roots as well as dead tree roots. And so if you have an area that has laminated root rot, and it usually is in sort of pockets or centers, and it spreads as the tree roots spread out and they encounter infected roots, then that tree becomes infected. So that's the way it spreads. So let's say you have an area that's 200 feet across where the soil is infected, and as the tree roots grow, it can tend to spread like a foot a year out as it encounters new roots. So the fungus itself can grow through the soil, but then the tree root grows to the area with the fungus. As trees get bigger, their rooting crown gets bigger, so they reach out and touch the infected soil. That's how they spread. One way to stop a disease like that is to know it's there. First, you survey for it and identify it, which we have guidelines to help you do that, or you can hire people to help you do that. And then to, unfortunately, remove all the sick trees and plant something that doesn't get that root disease. And so laminated root rot affects quite a number of conifers, but western red cedar and the pines and all of the hardwoods, alder, oak, maple, are immune to that. So in nature, those would naturally tend to fill in where the Doug firs are being killed by laminated root rot. Those trees naturally fill in over decades. In our case, we could remove the sick trees and put healthy trees in. And then over time, the disease would die out because it doesn't have any host to grow on. But over time, meaning 50 to 100 years. So it takes a long time. And one of the reasons we have so much laminated root rot is just either accidents of history, and that a stand grows up to be 100 years old and then maybe it's got 10% root disease and then it burns, and a bunch of Doug fir comes back into that 10% of infected soil, and all the little trees, it spreads again. And so another 50 years go by and you'd have that much more root disease. Whereas if we intervene and purposely put something there that's not susceptible, maybe it wouldn't last so long. Next question.
All right. James asks, what will harm ponderosa pines but not adjacent firs and oaks?
Hmm, that's a good question. Well, so bark beetles, ponderosa pine bark beetles. Bark beetles are usually specific to a species or genus of tree. So a lot of the bark beetles that attack pines, and pines can be pretty vulnerable to bark beetles. Those same beetles will not attack Douglas fir or cedar, or other species. Um, not too familiar with this. There are some diseases that would attack pine more than fir, but generally not. Generally, there are some of the root diseases that attack a variety of species, like armillaria root disease, for example, and it would attack both pine and fir. We do have some books that sort of give you a rating of which trees get which diseases and then which ones cross over. But generally, the main thing with pines would be the insects that attack pine and not other species.
All right. So Jordan asks, how are weeds managed in a new plant outs and for how long? I live adjacent to a new plant out, 1 to 2 year, that has had annual weeds out of control, up to 5 foot tall with dense, dry, branching flower stalks. And she's concerned about the fire risk from the annual dieback in the autumn and increased fuel ladder to our mature trees.
Yeah, it sounds like that's your neighbor's uh, area. So um, not always easy to advise your neighbors, but in general, the weeds, if you're focused on establishing trees, foresters and woodland owners tend to say, well, how much is just enough weed control? Because it costs time and effort and money to do weed control. So how much is enough that the trees are going to make it and take over? So the best weed control long-term is that the trees win and they shade the weeds out, they dominate over time. And with Douglas fir, that works great. As you saw in it works too good. If you want something else besides Doug fir, don't let so many Doug fir take over because they'll kill everything else. Um, so normally we look at like a 10-year window that the Doug fir are pretty much going to take over, or cedar, hemlock would be a little slower, but they would do similar things. Um, so you might see more weeds than you'd like to see, even though the trees are going to make it, and then it might take 5 years before the trees start to dominate enough and the weeds start becoming less. So a lot of landowners aren't going to try so hard to control the weeds. They're going to go through a phase where there's 4 to 5 foot weeds out there, and that's part of normal forestry. So you might, for fire mitigation and things like that, we may want to do something that's above and beyond because of the threat to a home or a building or something of value. Deeper in the woods, we do enough weed control usually in the first 2 years, and then after that, the trees are going and the weeds might grow back a little bit and might go through a fire hazard phase, but it only lasts a few years. And then the trees become the fire hazard. But they're different, of course. They're starting to grow up taller. Um, there are many methods, though, for growing, for influencing the weed community so that maybe you have lower growing weeds. You could favor shorter weeds over the taller weeds, depending, like, blackberries and Scotch broom and brush could be taller versus the annual, um, you know, senecio and daisies and thistles and grasses. You, a lot of folks use herbicides in different mixtures to selectively manage what kind of weeds they're going to allow. They generally never kill them all, but they end up saying, well, I could have grass or I could have no grass. I could have thistle or no thistle. They would use herbicides to control that. Short of that, then, annual mechanical treatments, something that knocks it down periodically, is really the only option if you don't want to just wait for the trees to shade things out. That's maybe an oversimplification, but that's kind of one way to look at it.
Great. All right. So Evan asks, what resources are focused on white oak?
Resources, you mean like educational resources or, more information type resources? Is that, let's assume that's what it is. There are, well, I think, doesn't the Marion SWCD have an oak management program?
We don't have a specific oak management program, but we assist folks with oak management. So we have our landowner assistance program, which is kind of an umbrella program. And one of the things that we help people with is oak management.
Yeah, and there is a growing community of landowners, particularly in that Willamette Valley area, of course, where the oaks, are native, and we'd like to bring more back. There's quite a community of people focused on oak management. We have a Tree School online class about oak management coming up on February 16th. So Connie Harrington is going to talk about biology and management of Oregon white oak. Then that taps you into some resources in the communities that are trying to do that. The metro government up in my part in Clackamas and Washington, Multnomah County, they have an oak management program and they're restoring oak woodlands. So there's a fair amount of resources out there. That's another thing where you could, send me an email and ask more questions about that. And I'd say the best thing would be to look for a tree school online. If you just Google that, I realized I didn't put that in my resources. That's something different we're doing in COVID times is our tree school online. So I will add that to the resources. But the February 16th tree school online will be about white oak. And those are recorded too, so you can go back and watch them later if you're not available that day, which is 3 o'clock on a Tuesday.
All right, great. Let's see. Jenny, do you want to take it?
Sure.
Go ahead.
Can you hear me?
Yes.
Great. So the next question, are there ecological consequences to planting trees that are not historically associated with your forest region, even if the conditions are suitable? For example, planting lodgepole pine or redwood in an area that has been a Doug fir and hemlock habitat. And then the second part, I'll just hold on to that, but it's managing for habitat ecological benefit. Wondering, especially in terms of climate change, if our burn site is rocky and steep. I'm just wondering about planting madrone in sunny slope areas.
Yeah, so I mean, the first part of the question, yes, there are ecological consequences of planting a lot of something that, wasn't here recently. It wasn't here before. So we normally focus on locally adapted native species in forestry and in conservation restoration. And so we are cautious and generally don't like to plant a lot of what we call exotic species for a couple of reasons. One is if you planted a lot of, let's say, lodgepole pine and something else, they might turn out to be maladapted. They would just end up getting sick or creating an attraction to an insect outbreak or something because they're going to not be adapted to the climate. Then, of course, they just wouldn't thrive and meet your objectives to have a healthy woodland. Even if they weren't attacked or dying, they just might not do very well. And also, we generally don't advise that. But then in the case of climate change, we are starting to question our assumptions, because the way that we look at forests now is that they've adapted to a climate that's been more on average kind of stable for a while. Of course, in the long run, 15,000 years ago, it was a much, the glaciation period, and coming out of that, it went through a lot of phases, and our current Doug fir, hemlock, Cascadian forests only really became predominant over the last 6,000 years. So now with climate change, the threat of climate change, we might see much more rapid changes, and we are talking and thinking, asking scientists about assisted migration and purposely, but with some intelligent guesswork, moving species like incense cedar, for example, that's native in the southern Willamette Valley and it's drought and heat tolerant. Incense cedar might be moving up the valley, and that's something we might plant now that we wouldn't have planted 20 years ago, because it's a reasonable guess that that might be better adapted in the coming years. Coast redwood is another one that folks are really looking at because it's adapted to a climate just to the south of us. It's a very tough tree and a high value tree, things like that. But so intelligent guesswork at assisted migration is on the drawing board, but I don't have guidelines for that right now. And if you ask the Department of Forestry, who enforces the rules about reforestation, they're generally not, they're going to reject the idea of planting too much of an exotic species. They might allow you to experiment with a few here or there.
I hear that, and I think that's the second question that we had, just talking about how the zones have changed, and would you recommend then planting Northern California tree species?
So one of the things we're looking at probably not that far. We're talking about moving 1 or 2 seed zones, let's say, and that's a concept that I didn't have time to get into, but the way we look at ensuring local adaptation is first we study the genetics of the individual species and we see how broadly adapted are they. Douglas fir is narrowly adapted. Doug fir from Roseburg would not be adapted to the climate in Portland, and it would get sick more than a native Portland Doug fir. So even within species, we look at moving seed zones, and we are talking about, in the face of climate change, maybe taking Douglas fir from Roseburg and planting it in Eugene, or maybe up towards Salem. That's just within Douglas fir because it's so specific. It grows from Southern California to mid British Columbia, and so that's broad range. But in the case of species, again, we might look at something like incense cedar or redwood starting to shift north a little bit or up in elevation a little bit, but not a lot. And there's a lot of climate science projections and modeling that's behind that. One of the challenges, though, is if you plant that Doug fir from Roseburg now in Portland, in the next 10 years, it's likely to suffer from it being too cool and moist. In 50 years, it might be adapted to that location, but if it doesn't survive the next 10 years, or it causes a disease problem. For example, planting a large area to a maladapted seed source of Douglas fir is something that's gotten us in trouble in the Coast Range with Swiss needlecast disease, which is now on 500,000 acres. That we planted Doug fir before we knew how narrowly locally adapted it was. And so when they replanted the Tillamook burn, they planted Doug fir from all over the West. And a lot of those Doug fir got sick because they were not adapted to the local climate, and a local disease became an epidemic. So that's the short-term risk, is that we face that. Longer term. So what we're talking about doing is maybe hedging our bets and mixing it up a little bit, but not entirely replacing local species.
These sound like incremental
Yes.
changes.
Yes.
And Karen and I said, what is the worst that can happen and the best that can happen? So that Swiss needle was the worst. And what's the best is taking a local ecotype. I think that's all the questions in our chat. Glenn and Sarah, I think we covered them all unless there's anybody that had any that popped in.